Now let's look at a few examples. First one, the probability of hitting a target per shot is 0.2. Okay, so the probability of hitting the target per shot is 0.2 and 10 shots are fired independently. Okay, so you know you're dealing with the binomial distribution because we've got 10 shots, in other words, 10 trials, and the probability of hitting the target on any trial is 0.2. So the probability of success is 0.2. So let's write our binomial. X is a binomial random variable with a binomial distribution. What is n? 10. Okay. And what is p? The probability of success is 0.2. Good. So we have defined our distribution. X is a binomial random variable with n equals to 10 and p equals to 0.2. So now we can answer the question. What is the probability that the target is hit at least twice? So at least 2 successes. So at least 2 successes will be bigger than or equals to 2. Okay, so that's what I've done here. And remember, we have got, let's draw a number line just to learn it well. I have 0, 1, 2, all the way up to 10. Okay, what are these numbers here? These are the values X can take. So you want probability X bigger than or equals to 2 should be from here on, right? So that will be 1 minus, we take the complement, probability X less than or equals to 1. Okay? We want 1 minus this and this. So that's what I've written here. The formula itself you can do it yourself, right? It's NCR, yeah, remember? It's NCR, PR, Q, N minus R, right? So when you want to work out probability X equal to 0, so R equal to 0, you will get this, yeah? Okay? When you want to work out probability X equals to 1, R equals to 1, and you will get this. Remember, N is 10, right? And P is 0.2, so Q must be what? 0.8. Good. So use a calculator and we are done. Great. So we're done with part A. What's part B? What's the expected number of successful shots? We know the formula. We have learned it before. NP. So it'll be 10 times 0.2 will be 2. Okay. The expected value of X. Part C. How many shots must be fired to make the probability at least 0.99 that the target will be hit at least once? At least once means what? Probability X bigger than or equals to 1, at least once, is at least 0.99. So must be bigger than or equals to 0.99. Excuse me. Okay, so that's what I've written here, bigger than or equal to 0.99. Okay, so we know that probability that X is bigger than or equals to 1 must be equals to what? Take the complement, yeah? 1 minus probability X equals to 0. That's it. So use a calculator, okay? Plug in your numbers. Be careful about inequalities, yeah? Be careful about inequalities. I've done it here carefully for you. We have an inequality, probability X equal to 0 is less than or equals to 0.01. And then you can plug in your formula and you'll get this, okay? Do a little bit of, what do you call it? Log operations, yeah? So do a bit of log operations. And then what we'll see is the answer coming out, yeah? So just be a bit gentle with logs. I'm not going to talk about logs here, but you can see you're bringing the n down, training up a little bit. Careful, okay? When you divide by negative numbers, then the sense of the inequality must change. Those are things we learned in a basic algebra class. Sort that out, and you'll get n bigger than or equal to something. So your value of n bigger than or equal to 20.63 should be what? 21, 22, 23, and so on. So we'll just take it as 21. Okay, done. Let's look at the next example, right? Let's look at the next example. Okay. Let me look at my sheet of paper and see whether I have anything that I have missed out. Sometimes I make some notes here to tell you about it. No. Okay. So next example. If X is the number of sixes that turn up, okay, the number of sixes that turn up when 72 ordinary dice are independently, can you see, are independently thrown, find the expected value of X squared. So basically, what are you doing? You are throwing 72 ordinary dice, yeah? Okay. Now, one way of thinking about it is you throw one die 72 times. Okay, that's another way of looking at it. Okay, instead of looking at, you throw 72 ordinary dice once, basically you're going to throw one die 72 times. So when you do that, you can write it as a binomial random variable. X is binomial with n equals to 72 and getting a 6, right? So you have 1, 2, 3, 4, 5, 6. So the probability of a 6 is what? 1 over 6. Done. Okay. Then the rest is easy. You ask to find the expected value of X squared. So all you need to do is what? Find the expected value first. Okay. You know the formula, NP, and then find the variance of X, NPQ, and then use the formula. Second moments minus first moment squared is your variance, and you can get all your answers. No problem, right? So I have got NP, right? So you take 72 times 1 over 6, you'll get 12. That's the expected value of X. Variance NPQ, so it'll be 12 times 506. Okay. You will get your answer 12 divided by 6 is 2 times 5 is 10. So then you take variance of X is 10 equals, right, the expected value of X squared, oops, minus the expected value of X whole thing squared, right? So the expected value of X squared will be 10 plus 12 squared, okay? 10 plus 12 squared, you'll get your answer. Enough about that, yeah? Let's clear the screen. Next example is a question that appeared on an old Society of Actuaries exam. So let's read the question. We may not have to do all of it, okay? Let's just talk through it, okay? The probability that a particular machine, right? No, am I reading the right question? Yeah, okay. The probability that a particular machine breaks down on any day is 0.2. Okay, let's keep that in mind. Okay, probability that a particular machine breaks down on any day is 0.2. Independent of its breakdown on any other day, the machine can break down only once per day. Calculate the probability that the machine breaks down 2 or more times in 10 days. So this one you sort it out yourself. We'll just talk through a little bit. Okay, we are looking at X is binomial. Hang on. How many days are we talking about? 10 days. So n is 10. Remember, it can only break down once per day. What's the probability of breakdown? 0.2. Okay. So we asked to find breaks down 2 or more times. Okay. So probability X bigger than or equals to 2. So that will be what I've written here. And then you can go ahead and remember less than or equal to 1. Remember it's 0 or 1. So this is the case when X is 0. This is the case when X is 1. Plug in all the numbers. Remember, we're using the binomial formula. Use a calculator and we are done. Okay? Great. We have a small commuter plane, has 30 seats. The next example, right? A small commuter plane has 30 seats. The probability that any passenger, okay, that any particular passenger will not show up. Oh, a plane has 30 seats. The probability that any particular passenger will not show up for a flight is 0.1. So that means what? The probability of showing up Okay, let me write it here. The probability of showing up is how much? 0.9. Okay, so will not show up for the flight 0.1. Independent of other passengers, the airline sells, it sells 32 seats for the flight. Okay, great. Calculate the probability that more passengers show up for the flight than there are seats available. So which means, remember the plane has only 30 seats. So you are selling how many tickets? 32 tickets. So let's write down. Oh, let's look at my solution, right? We can define our binomial random variable. X is binomial with N is 32 and P is 0.9. I've written that here, right? Of showing up. So X is binomial, N is 32, P is 0.9. Now, you asked to find the probability that more passengers show up for the flight than there are seats available. So probability X bigger than 30. So X bigger than 30 will be what? X equals to, bigger than 30 will be X equals to 31, or, so we had plus, yeah, X equals to, oops. So bigger than 30 must be 30 or 31. So we have a binomial distribution here, and plug in the values in a calculator for X equals to 31 and X equals to 32, and you'll get your answer 0.156.